Welcome everyone to our Raspberry Pi Foundation Computing Education Research Seminar. I'm Sue Sentence and I'll be chairing today's seminar. This is the final seminar in our series. I can't remember how many we've had now, sorry, on somebody can tell me, in our series on cross-disciplinary computing. So in this series, we've just been able to look at a real breadth of topics. If you track back over the things we've done about learning computing in different settings and different subjects, and today we're really excited to be focusing on non-formal learning in computing, which is really important to the Raspberry Pi Foundation. This is the last session in this series, and we're going to have December off. And in January, we start a new series, which we'll be announcing at the end of this session. So I'm delighted to introduce Tracy and Rebecca. Tracy has a PhD in computer science, has worked in academia and industry, as well as teaching primary school computing. She's got loads of experience with Code Club and Coder Dojo, and she works in our informal learning team developing projects. Rebecca has over 15 years experience teaching computing. She's part of the leadership team and has experience working on Pupil Premium initiative. She now also works in the informal learning team for Raspberry Pi Foundation. Between Tracy and Rebecca, they're going to talk about the computing education work that we do at the non-formal work that we do at the Raspberry Pi Foundation, and also a recent research project that we carried out, a literature review that we carried out. I can hand over to you now. You can share your slides.
And thank you everyone for coming. We are Rebecca Franks and Dr. Tracy Gardner, and we are here to talk to you about computing education in non-formal settings. So just to break down this talk for you, I'm going to talk about 321 Make, which is our research informed framework that we use at the Raspberry Pi Foundation for non-formal computing. Tracy's then going to talk about the literature review into computing, and then I'm going to give you a bit of an insight into what's next. And Sue's done a great job of introducing us, so we don't need to talk through this slide too much. It's just, yeah, so I've gone from formal learning to informal learning, and I'll talk about that a tiny bit as I do my talk, and then I'll just introduce for you as well Dr. Tracy Gardner.
Thanks, Becky. So yeah, Sue did a fab job introducing us. I think one of the things that I'll kind of mention about my background is how I entered computing as a career and a discipline, because outreach had a huge impact there. I came from a family where nobody had got any academic qualifications, never mind going to university, and outreach activities, non-formal activities, were my way into computing as a career and a discipline, as well as to university. So it's something I've got a really personal link to. And as Sue mentioned, I've got this mixed background of academia. Most of my career spent in industry, mostly with IBM as a software architect. And then I moved into education because basically I love computing, and I just want more people to be involved in computing and digital making. And I just want to share that and put out, a positive, accurate view into the world of what it's really like to be involved in computing as a profession and a discipline. Okay, so we thought we'd start off giving you a bit of context about who we are and how we fit into the Raspberry Pi Foundation. So first of all, the Raspberry Pi Foundation is a charity with an education mission, and we are linked to the Raspberry Pi hardware, but we don't actually produce the hardware. So I think putting that out there first of all. So Becky and I are part of the informal learning team, and we develop content for our programs, including code clubs, coder dojos, and coolest projects. I'll give you a bit of an overview of what they are in a moment. And we sit alongside the research team, which Sue and others who you've heard from in these seminars are part of. And that's linked to the Research Centre, which is a collaboration with the University of Cambridge. And as you'll find out in this talk, our two teams collaborate inside the foundation in those areas where we intersect, and that is research into computing in non-formal settings. So another thing we thought would be useful to have at the beginning is a definition of non-formal computing education, or what is non-formal education. So this is the definition that we prefer. It comes from a UNESCO report, and it describes non-formal education as institutionalized, intentional and planned by an education provider. So in our case, the Raspberry Pi Foundation, through programs such as Code Club and Coder Dojo, we are the education provider. And non-formal education is an addition to formal education, and it's part of that lifelong learning journey that everyone goes on. And I think one thing I would add that's really important is it's typically optional. So that can be optional on the part of a young person, or sometimes on the part of their parent. So that's one of the big differentiators from formal education. So just to give you some idea of our programs. So Code Club is a global network of free coding clubs that covers the 9 to 13 age range. So that's primary or elementary school through to middle school or early high school. And that's in 160 countries at the last count. Coder Dojo is a community of free local programming clubs with a wider age range, that's 7 to 17 in over 100 countries. Code clubs are typically in schools. Coder Dojos are more likely to be found in libraries and community centres and other venues. Coolest Projects is our showcase, where young people can contribute projects that they've made with technology, whether that's code or physical computing. It used to be just a physical event, but since the pandemic, it's gone online, and that's really led to increasing international participation.
So I'm going to chat to you. Yeah, so I'm going to chat to you about our 3-2-1 Make framework. So what problem are we actually trying to solve with this framework? And you may or may not have heard of something called the Turing tar pit. And Alan Perlis said, beware of the Turing tar pit in which everything is possible, but nothing of interest is easy. So we've got all these great, some not so great programming languages out there, and our young people want to make lots of things, or they might actually want to make something, but not be quite sure what they want to make. And they'll go and start, and they'll get quite frustrated. Because they'll have tools to support them, and they won't really be able to make decisions about what next, and where do I start, and now what do I do, now what to do, and they'll get very frustrated in that sort of cycle of trying to get something done. And what we really want to do at the Raspberry Pi Foundation is get young people to make things that matter to them. So what we do is we provide beginner-friendly libraries so that it becomes more beginner-friendly words in that code, and I'll talk a little bit about that later. Faded scaffolding. So you've probably heard of the pedagogy scaffolding in order to prepare learners for the skills that they're learning, and we do that in our framework. And those important design skills as well, which are sometimes missed in these kinds of programs, is getting our creators to actually know how to design things so that they can start to answer for themselves what is next in this process of this project that I'm making. And we didn't just pluck this framework out the air. Absolutely tons of research went into getting this framework right. We talked to our community to see what kinds of things they wanted to do in the clubs and online as well, what interests they had. We looked at existing projects that were out there, so ones that we'd created, but also in other areas as well, like code.org, for example, and see what they were doing. We came to the decision that, like, computer science for what? So looking at things like creativity and social action and things like that. So we wanted to make sure our paths included those things. And we really did focus on research, and the research seminars helped a lot with that in pinning down the research that we could use. And then also looking at those pedagogy techniques like scaffolding, UDL, Universal Design for Learning, cognitive load. Worked examples couldn't fit on there, but we use a lot of those in our programs, and data as well. So tons of research and data and all sorts went in to making this 3-2-1 framework. So what actually is it? So what happens is we've got some Discover projects. Discover projects are for young people that might be, they might not know at all about programming, and you might think, okay, well, we'll give them a Scratch Discover project to see if they like it, so they can try it out. And if they like it, then they'll go on to do our Introduction to Scratch path. If they've got a bit more experience and they might want to try out the web, for example, then we could give them a Discover project on the web. And if they like it, then they can do our path on the web. So a Discover project is just something to discover that software or hardware to see if it's something that interests them, that they might want to do. And then when they're on their path, on our paths, our learning paths, they start this 3, 2, 1 make process. So we start off with 3 explore projects. And these are the traditional step-by-step projects. If you've looked at our projects before, they step learners through making a project. They get a couple of little design decisions on there, but it's very scaffolded, that one. And that introduces them to all the new skills that we want them to gain in this path. Then we have 2 design projects, and this gives them chance to revisit those skills that they covered in the explore projects, but now they're making more design decisions about the products that they want to make at the end, or the artifact that they're designing. And then they have an invent project, and this again is removing that scaffolding a little bit more. So the invent project gives them even more chance to personalize their project, and they can actually decide which skills that they want to use in order to make their invent project. And then they jump off the path, and they hopefully have had lots of exposure to those new skills throughout the path. And then they can go and make something that's unique, that they can make independently. And if they want to, they can enter that kind of project into call-list projects as well. So that can seem very abstract. So now I've got an example for you to see. And we love a good diagram or picture in the non-formal learning team. So if you just take a look at the left-hand side there at our explore projects. So these are some of the Scratch projects that our young people have made. It's our Space Talk project, that one. So if you take a look, I know they're quite small, but if you take a look at those screenshots, you can start to see that they're all fairly similar. So you can see probably 3 sprites on each one. They're roughly the same sprites. Almost all of them have got the same background, but there's just some subtle differences. So you can see there that there's been lots of scaffolding. They've been following something step by step, but there's been a little bit of tweaking when a young person has decided, you know what, I prefer that background, so I'm going to put that in. So we don't completely restrict them, but they are very scaffolded at that point. And then if you just draw your attention now to the middle of the screen, this is pictures of Silly Eyes project. So this is a design project. And you'll notice now with the Silly Eyes project, they design a face with eyes, and then the mouse moves around and the eyes follow the mouse. So it moves around. And you'll see now we've got a scaffolded project in a way, because they're all making a face. They've all got eyes and they've all got a background. But we're starting to see more personalization, more design decisions being made here. So still a little bit restricted, but now we're making our design choices. So we're just helping them on that journey. And then finally, with the invent project there, they all do that. I made a book, so they're all making an interactive book. But you can see now in those screenshots of those projects that they are pretty unique. Pretty much every single one is different, apart from I think there's just a couple where they've used the same stage, same backdrop on their thing, but they've got very different approaches to that final invent project. So hopefully that helps you to sort of visualize sort of like this scaffolding and fading that we do. And I'm going to talk a little bit about my personal journey with using this framework. So I came from the formal learning team. I've got a lot of experience in formal learning. And when I joined the informal learning team, I was told about the framework and given a sort of a rough introduction like you've just had. But what was really great for me was actually experiencing the path myself and how the framework really works. And a good test was one of my first jobs in this team was to test our new Unity path. And it was a great test because I had not used Unity before at all. I'd not coded in C# before, and I hadn't really done any creating 3D worlds at all. So this was a really good practice to see, well, does the framework work on me? I know, like, I'm an older person and that kind of thing, but does it work on me? And what I really loved about the path was how I could relate it to my own experience. So I'm a massive Mario fan. I love the 3D games. And there were the words that introduced to me, like particles. So when you're playing Mario, you look around for little particles, and if you find one, you do a sort of dive bomb onto it, and you get a coin or a heart or something like that. And I didn't really even know that word existed. So I just thought, oh, this is just something they've invented in Mario. But actually, this is used in quite a lot of games, and this taught me that. And it taught me about collecting objects and non-player characters. Of course, I've seen non-player characters, but did I know that's what they were called? No, I didn't. So I learned these skills as I went along. And as I started working for this path, I did my explore projects, and I got to really understand where to type the code and how to test my game and how to change things, how to debug. All those sort of skills were built up in that explore task. And then when I got to the design projects, I started to think, oh, what game might I make for my invent project? And I started to tick over and get quite excited to think about, what could I do? What matters to me? What would be a cool game to make? So I made Scramble Trail, which you can all distract yourself now if you want to for 5 minutes. And follow that URL. You can play my Scramble Trail game. But that was a thing that I wanted to do because I like sort of Mario Kart type things, and I wanted to collect the stars as I go around. And the beauty of it is I suddenly felt so confident that I could do it because I had all that scaffolding that got me to that point. And the great thing about the invent projects, that final project, is it has loads of reference materials to remind me of those skills. Because, you know, let's face it, we learn things, we forget things, but it's nice to know, I know what I can do in Unity, the path showed me, but then I also knew where to remind myself as I was building my own project. So for me, I can definitely advocate for, on me, this framework worked really well. So then my next job was to work with Tracy and one of our other colleagues, Liz, on our Raspberry Pi Pico path. And if you've not heard of the Pico before, it is a low-cost microcontroller that you can plug into a laptop or a computer, and you can code it to do all sorts of things. A little bit like a microbit, a little bit. Okay, so there's some similarities there. And this is just another way, another diagram that we use to kind of show people or the progression of skills and how it works. So if you look at that top row, you'll see the 3 explore projects that are in that path. And you can see that the components that are introduced slowly, step by step, in those explore projects. So we've got a buzzer, we've got RGB LED and LEDs and potentiometers, which is just a dial, if that's a scary word for you. It was a scary word for me about 8 months ago, but it's not anymore. So we've got those skills that are introduced at the top, and then if you look in that bottom left hand corner now, you can see we've got the mood indicator and the sound machine projects. And this is where creators have learned those skills in the explore projects, but now they're revisiting those skills again, and they're making design choices. So if they want an RGB LED, they can pick one of those. If they want just a standard one, they can. So they've got those design choices, but with that scaffolding again. And then finally, if you look at that sensory gadget there, you can see, well, now they can pick any component that they've covered through that. So that's just another way that we show sort of progression of skills as we're going along. And I've got that little Pico Zero in the bottom left-hand corner there, just to remind me of how awesome Tracy Gardner is, and Martin O'Hanlon, who developed our Pico Zero library. Because when we started looking at the code for MicroPython, and we were thinking of the age group that we needed to pitch this to, we were looking at words like PWM, high, low, IRQ. These are all words that, did they really need to know at that point? Not really. So they went away and they made a library. So now when you want to blink an LED, you just do led.blink and it blinks the LED, and you don't have to mess about with all that other extra code. It's made it really beginner friendly. So that's just something else that we do when we're writing paths, is try and build libraries and tools for our young people too. This is something I bought from the formal learning team, which is a learning graph. So it's just another way to show progression of skills. If you're interested in looking at that, there's a short link on the screen, and we will share this later as well. It's just another way to see all the skills that are covered, how they're linked together, and how they progress through a path. And then we've got this last slide to showing you the paths that we've got. So these are all the software packages that we've got and the hardware that we're using. So Scratch, Python, the Pico, Unity, and our new one, which is the web. There's lots of materials for our young people to use, and there are other levels as well. I know the ones on the screen all say introduction, but we do have higher levels as well. It does work them through. So Scratch, for example, has got more Scratch and further Scratch as well. So there's lots for our young people to be getting on with. But we aren't done yet. We're always learning, and the thing that we absolutely love is we've got a really great community giving us lots of feedback all the time, and we're also constantly reading the latest research as well to try and make sure that we are doing the right thing and getting better. We want to make better tools for our young people so that they can get going really quickly and make things that matter to them, and we've already sort of looked at libraries, and we want to keep doing more of that, just so that we've got that greater accessibility. That's something that we are really putting at the forefront of everything we do. And that is a big priority for us. So I'm going to pass over now to Tracy.
Thanks, Becky. So I'm going to talk to you about the literature review that we did in the Raspberry Pi Foundation. This was a collaboration between me in the informal learning team and my colleagues in the research team. So shout out to Hayley, Jane and Sue there, who were involved in this piece of work. It was presented at the ISA conference this summer by Jane, and it's currently available as an open access paper. So you can follow that, you can read the paper, you don't need access to any database, anyone can read that. Okay, so what was this paper all about? So we set out to do an overview of the research that's been done in non-formal settings for computing education. We scoped this because there are a lot of papers out there that meet that criteria. We scoped this to age 5 through 18, so school age. The interventions involved had to be at least 5 hours. We looked at only physical settings. That isn't because we're not interested in virtual settings. We're very interested in online education. But at the time we were doing this, it was during the pandemic, and we could see a lot of programs were moving online, and that research would be coming out later on that. So it felt like the wrong time to be focusing on virtual settings. So we looked at physical settings. The papers had to have computing as a focus rather than using computing, but really focusing on something else like STEM in general. The papers needed to have substantive impact data so that we could actually see some conclusions. And we looked at the period of 2015 through to the time that we were doing the study in March 2021. So it's a fairly short time period. So this really looks at recent research. That's partly because other studies have been done prior to this, and we wanted to look at a time period that hadn't been studied, and partly because after that period, in quite a lot of geographies, there was starting to be formal education on the curriculum. So there was actually a sort of change in the landscape at that point. So what did we look at? Our first research question was about the focus of these papers. So the who, what, where, when, why topics. Our second question was, well, what did they find? What was the impact? And we synthesized the findings across these 88 papers. So yes, I read 88 papers more than once, looking for all the information that we needed. So we did this as a systematic review. So we followed a strict process of identifying keywords and searching databases and applying inclusion and exclusion criteria. So this is done to avoid bias. So we didn't want to just choose the papers that we happened to know about. So this is a very systematic approach. It's not exhaustive. There are lots of papers we won't have picked up, but we had to scope this in such a way that we got a set of papers that was manageable. So we followed this process. That there's the full detail of the method for this in the paper, and out of the other end popped these 88 articles. So just to give you an overview of what kind of papers we found in there were papers that were case studies that looked at the journey that young people went on. There's one there that looked at the emotion, problem-solving identity of 3 girl coders as they were involved in a regular computing program. There was a paper that looked at a summer camp, and fairly unusually for the set of papers, looked at the long-term impact. So what happened after, what happened next in terms of education choices and career choices of those young people after they've been involved in that specific intervention. There was a paper set in refugee camps in Nairobi in Kenya, where they, as well as looking at computing education aims, they also had intercultural objectives where people from different tribes were mixing together in a productive way, and they looked at that context. There were papers that looked at young people creating apps, and some looked at what was the impact of the same intervention on different demographic groups, in one case different socioeconomic status, and there was one that looked at what happens if you get young people to try and solve problems from a real community and link them to a community and solve real problems that are out there. So it just gives you an overview of the kind of papers that were in there. There was lots of breadth and lots of depth. So what did we find for our first research question? So first of all, what kind of learners appeared in these programs? So most of the studies were focused on the US. Now, there is an aspect of this which is a limitation of the study, the databases we chose, the fact that we could only look at papers that were published in English due to the scope of our study. So there's definitely potential there for other studies to contribute and fill in gaps that we weren't able to look at. But I think we would say, even given those factors, still the papers were overwhelmingly from the US. The papers were mostly looking at the middle school age group. Again, we think this is linked to that US predominance in the studies. There were a lot of female-only cohorts. There were lots of mixed cohorts too, but there was a real focus on how do we get more females into computing. And there was a general focus on broadening participation, which looked at factors such as race and ethnicity and socioeconomic status. But in general, we found a lack of detail on socioeconomic status, other than those papers that had really focused on that. That's quite difficult data to gather. It's important data, but we found that quite lacking. We also found a lack of focus on disability. So there was one paper that specifically looked at young people with physical disabilities, but that wasn't generally a reported characteristic across other papers. There was also a lack of focus on neurodiversity. So then we looked at the providers and the purpose. So who were the education providers and what were they trying to achieve? So most of the studies were university organised, and often the university faculty were involved in the running of the intervention. We did find some studies by non-profit organisations and makerspaces and so on, but they were much more limited. Now, we don't think that reflects what's going on in non-formal settings in computing in general. We know there's a lot of other stuff going on outside of that, but that's what we found in the papers that came through in this review. So again, that's scope for further research in future. What were they trying to do? Well, the most common purposes were broadening participation. So that was trying to bring groups into computing that have traditionally been underrepresented. And also interest development, where the focus there was more on getting people to get more involved in computing and choose computing as an option for university and as a career. Most of the studies were in immersive settings, so they were often in summer camps run by often the universities. Sorry, Becky. What computing topics were looked at? So we saw a lot of game development. I don't think that'll be a surprise to anyone. There was a lot of game development. There was also a lot of app development represented. And we also found, in terms of programming, there was a lot of studies that covered general programming, and that included a variety of different topics. So that might be a summer camp that did a little bit of game development, a bit of app development, and a bit of like story creation across the course of a week. And what outcome measures did the papers look at? So we looked at two main categories, cognitive and affective. So in line with the focus on broadening participation, the affective constructs were more prevalent. So we found more studies and more measures looking at affective constructs, where they were things like interest, perception, engagement, self-efficacy. So how did the interventions change the mindset of those young people towards computing? Those measures tended to look at surveys, interviews, and focused case studies. One of the topics that came through was that sometimes gathering that data was difficult in these settings because it could be seen as boring and a distraction from actually getting on with the fun business of making things. So the papers were often quite respectful of that and wanting to gather more data, but also wanting to meet their goals of making computing more appealing. And I think one of the things we looked at was, are there ways to do both would be interesting for future work. But there was also a lot of representation of cognitive constructs, looking at knowledge and skill development. There was use of pre and post tests, a lot of artifact evaluation, particularly when looking at skills, and focus case studies that looked at how knowledge and skill developed over the course of an intervention or repeated regular interventions. So research question 2, what did we find? What was the overall impact of these activities? Now, I will say that these were very different papers that reported their findings in very different ways. So we weren't able to really do a very, very detailed comparison. But what we did was a high level synthesis across the papers of the themes that came out as we looked across them. So the cognitive measures, as you might expect, were broadly positive in general after an intervention. Usually we found that there was a positive result on the knowledge and the skills of the young people involved. So in more depth than that, we found there was some evidence that regular settings were beneficial, that young people who came back repeatedly, that actually deepened their knowledge. We found that active teaching of problem-solving skills was leading to increased independence. So young people were more able to create things that were different to what other people were creating. And also there was research around open tasks and the importance of those, actually for both cognitive and affective outcomes. There was some evidence that different demographics responded differently to the same intervention. So there's one example we've given there where learning gains were similar for male and female cohorts, but there was some evidence of higher scores for boys. So we think that may be linked to increased prior experience for the boys. So the girls had had less experience coming into an intervention. So while they made similar gains, the end point of the boys was further along. So that's something to consider. We also had all the case studies in these papers where you can really see that learning trajectory of the young people, those aha moments that really come through where something drops into place, or those moments of frustration where they're really thinking, oh, I'm never going to get this, and then at some point later they get it. So as well as all the data those pieces of information are really important, and we really see that coming through in the papers. So effective constructs. So these were mostly positive, but with the caveat that this was in the short term. Okay, so there was very little long-term evidence in these papers, but again, it was mostly positive, which is agreed with other similar reviews in the area. So we saw an improved perception and awareness of computing. Now, even over the short period of our study, we could start to see a slight change in this. The earlier papers were really trying to dispel negative stereotypes of computing. And by the time we get to the end of the time period, there's a lot more focus on just projecting a positive view of computing and an accurate view of computing, and not feeling such a need to say, no, it's not that, but really present this positive view of what computing is. So generally, the papers were able to increase the perception and awareness of computing. Now, I think the one thing to draw out there is that these were the papers that targeted that. One of the other things that came through was that you really needed to design studies with particular outcomes in mind in order to gain those outcomes. So there were other studies that measured these things but didn't have specific activities or designs of the programs that were tailored to those outcomes, and they didn't necessarily see the benefits just accidentally, incidentally, when they were focusing on other things. One of the other things that came through strongly was the improved confidence and self-efficacy was only there if you had a good match with prior experience. So if you were trying to do an activity that wasn't well matched to the young people and the experience they'd had previously, then you can actually have a negative impact on those factors. So again, that's something we've seen elsewhere in other research and is really important to keep in mind. We also saw a lot of positive benefits from the social factors, belonging to a community, having support. Parents get mentioned in several papers, how important the support of parents is, mentor relatability. So there are studies that look at near peer mentoring and matched mentoring. And there are case studies that really look at how we understand the emotional journey that those young people go on, the roller coaster of how they develop their identity, how they feel like they're a computer scientist when they are able to make something that someone else uses and says, oh wow, this is really cool. So those kind of factors really come through. So some of the young people really come through the papers, and you really get the feeling of the journey they were on. So that's one of the things that comes through strongly is yes, we can look at the high level overview, but just looking in detail at some of those individual stories is also really valuable. So we included in the discussion section of the paper a look at the affordances of non-formal computing. So looking across that set of papers, what does non-formal computing really lend itself to? So the first one we've got there is access and awareness. So young people often got access to computing education opportunities they wouldn't have otherwise, either because there's no formal curriculum in their geography, or because it was looking at topics that aren't yet on the curriculum. So things like artificial intelligence or data science or cybersecurity. Cultural relevance and equity was another really important area. So non-formal computing settings were able to take groups of young people with common backgrounds, common prior experience, and really look at what can make computing relevant to them. And there was also several programs that addressed previous inequity. So rather than just offering the same experience to everyone, they really designed programs that were intended to address gaps in previous experience, and they had some success with that. Practice and personalization is another one. You know, the ideal is young people get access to computing in school, and then in non-formal settings they really get to practice those skills, focus on the aspects they're interested in, and really bring in their own interests without the constraints of, you know, a formal classroom and curriculums and all the goals and everything you have in a school setting. Fun and engagement was another one. This really comes through in the papers. There's this real feeling that a lot of the instructors and program organisers appreciate that young people are giving up their free time here, right? They are choosing to do this activity. So as well as being an educational experience, it really has to pass as a leisure activity as well. So I think that's one of the kind of key differentiators with formal education. You know, in a formal setting, they pretty much have to come back next week, right? In a lot of non-formal settings, they don't. They could choose to go and play football or go to dance or art club or a different setting. So that really comes through. Non-formal settings provide an opportunity to develop communities of young people with common interests, to build their identity, to get access to role models they wouldn't otherwise encounter. And finally, immediate impact. This is, you know, been really important, really comes through. Young people aren't just learning skills because they might be useful in the future, either for exams or careers. They're useful now. They made a thing. They got to show and tell and showcase the thing they made. Other people use that thing. They might have made a thing to help their local community. That immediate impact comes through. And also in some of the papers, the other goals, such as the intercultural collaboration that can happen in the context of a non-formal setting. All of those things are really valuable. And we really saw it complementing formal education. The ideal would be young people get access to an excellent curriculum during the school day, and then they have opportunities to further develop their interest outside of school. And just quickly to finish off this section, what don't we know? Okay, so we don't know enough about settings outside of the US. We don't know enough about primary and elementary school. So I think there were only 9 papers that focused on that younger age group. And that is an age group that's really of interest to us at the Raspberry Pi Foundation, our code clubs and coder dojos. We have a lot of young people in those age groups. We were lacking really detailed demographic data, although I will say that our set of papers, we saw that this had improved since previous research. So Monica McGill and others have looked at this in the past, and we did see an improvement from previous time periods, but there's still a way to go. We don't know enough about regular meetups. So there were far more papers around these immersive multi-day settings like summer camps than there were regular weekly clubs. So we need to understand more about that space. Again, something that's really interesting to us. We don't know enough about young people with disabilities, also young people with special educational needs, neurodiversity. That was really lacking in the set of papers. Long-term impact, that's something we need to know a lot more about. We often saw positive results in the short term, but what next? What happens next? So there was some of that and it was really valuable, but we need more. Computing beyond programming, again, we saw some of that, but there was a real focus around programming skills. We don't know enough about which specific factors contribute to positive outcomes. So in a lot of the studies, we got a general view that this intervention had been successful at increasing these outcomes, but very few of them really drilled down into the detail of that to look at which specific factors in the design of the intervention led to those positive outcomes. And we need studies that we can replicate. So there's often not enough information in these papers for someone else to be able to run that study again with a different cohort and see if they get the same results. Okay, so that was a quick overview. The full paper is available. You can read all the detail. I've kind of seen some of the questions flying past about specific numbers and things. Those are all in the paper, but we didn't have time to go into all of those today.
Thanks, Tracy. That was really good. So I'm just going to tell you just a little bit about what's next. So as I said right at the very beginning, 3218 is research informed. We did a lot of research, well, Tracy and the team did a lot of research into getting that right at the beginning. And now our framework is out there in the world. We've got young people using it all over the world. So it's happening. So that research has informed our practice that we're doing now. But what we would like to do in the future, hopefully next year, is to do a research study to fill in some of those gaps that Tracy just spoke to you about there. So looking at independence, but also making a study that's hopefully replicable, that can be used in other countries, or other different countries that speak different languages and things like that, and just really filling those gaps in the research that we've just looked at there. So hopefully we'll be able to share the results of that research study at some point towards the end of next year. That would be really exciting. So we've got some discussion questions for you to think about. So the first one is, should non-formal learning focus on making it easier to make things that matter to young people? So perhaps maybe even comparing that to formal computing as well. And then the second one is, how can we better support young people in non-formal settings around the world with different cultural norms and education systems? So this is something that we are really passionate about, and we do have to think a lot about, because we are a global organization. So it'd be great to get your thoughts on that too. So over to the discussions.
Thank you very much. A big thank you to Tracy and Becky. Fantastic seminar. You complement each other well. It was lovely. Thank you very much. So thank you for those questions too. And you can see in the audience we've got people from all over the world who can answer your second question in the discussions. I think we'll wrap up the questions there. So can we again say a really big thank you to Tracy and Becky, and wave hands or electronic waves or whatever else your online behavior of choice. And just to say, we really appreciate your feedback on our seminars. We've been running them since May 2020, and we really have loved the fact that lots of people come back again and again to our seminars. So do tell us what you like or what you don't like, which ones particularly worked for you. And Diane has put the link on there. And if you've got any other comments, do carry on the conversation on Twitter.
So I'm really excited to announce that we're launching a brand new seminar series on primary. So primary is K to 5. So it's the younger age groups, and it's around, of course, computing education research. And we're going to kick off in January. And I'm very excited to say that we've got Katie Rich and Carla Strickland, who are going to talk to us about variables. Katie Rich has done the most amazing PhD, where she looked at all the very basic programming constructs that need to be taught, and she's kind of mapped out how that needs to be done. And she's not told us up until now how to teach variables, but she is at our seminar series on the 10th of January. So I do hope that you can join us. And we'll be running throughout the whole of the year. So these are just the first 3. Diana has put a link to the webpage that's got all of the speakers and topics. And although this is a primary school research, much of the work looks at how we teach these very fundamental concepts. So they're just as interesting for people who teach older learners and also in non-formal settings.
So thank you very much for coming along. Thank you.